Okay, today we're going to go backwards, which will help solidify graphing because we're going from graph to equation now. Okay. What do we need in order to be able to graph? First, we identify the amplitude, which is A. But is it A? Thank you, Sydney. That's the value of A. Okay. If A is negative, then our shape is different. Do you agree? Okay. Then we identify the period. How do we calculate that? Then we identify the starting point. C over B, comma D. Then we can draw our frame, and then we can draw on our curve, right? Well, what we are going to start with is the curve. So we will be able to pick out what the amplitude equals, we will be able to pick out what the period equals, and we will be able to pick out where the frame starts. Then we have to work backwards to get A, B, C, and D. All right? Okay. So, go ahead and draw what you can of this curve. It doesn't have to be super pretty, but at least have, you know, where it stops and the extremes here. Shannon, is this cosine or sine? Positive or negative cosine? Positive, because it makes a valley or a crater, right? So, you can identify everything from this curve. If it helps you, you could go ahead and draw the frame. Okay. All right, Kelsey, what's the amplitude of this graph? All right, the amplitude is 2 because it stretches over a total of 4. So A is going to be 2. Okay, Darby, what's the period of this graph?
2 pi over 3.
We start at 0 and end at 2 pi over 3. So if our period is 2 pi over 3, then 2 pi divided by B needs to equal 2 pi over 3. That's how we calculate the period, 2 pi over B. Well, if 2 pi over B equals 2 pi over 3, what is B? Okay. Okay. Now, here is where you need to be very, very careful. Remember that your starting point is where the frame starts. Hannah, where does our frame start? Our frame starts up here. Amanda? Okay, we have 2 coordinates. Which one does our frame start at? Our frame actually starts at 0, 0, because when we draw our frame, we draw up and down the amplitude. Just because our curve starts there doesn't mean that's our starting point. Okay? So for cosine, we're always going to begin our curve in the corner, but our starting point is always going to be right here in the middle of that frame. Okay? So our starting point is at 0, 0. Okay? I'm doing this example because that's a very common mistake to make. Okay? So since our starting point's at 0, 0, that makes our calculations for C and D easy. C is 0 and D is 0. So when we write this equation, we can write y equals A times cosine of bx minus c plus d. Yes.
So when we're looking at graphs, we're going to be looking at something similar to the frames you constructed.
Yes. When I give you a graph, I'm going to give you one period length. Okay. Yes.
Will we also be able to see the charts on this? Like we don't have to do the calculations.
Right. I'm always going to give you one period length, and so just go to the very left of where your graph starts and identify the starting point. Does that make sense?
I'm just in that instance we had 0, 0, so let's see how it's going.
If we have a starting point that's not 0, 0, is that your question? Okay.
You answered.
Okay. Now, some of you your wheels are turning. If I give you more than just one period of the graph, it's possible to write these curves in many different ways, right? Which is why some of you are a little worried. I'm only going to give you one period of the graph so you know which chunk you need to focus on, okay? All right. Go ahead and draw this graph for me. Jen, sine or cosine?
Sine.
Is this sine reflected or not? It is reflected, so I'm just going to go ahead and write that our A needs to be negative because we have a reflected sine graph. Okay. And Marissa, what would our amplitude be? Our amplitude would be 4. We have a total height of 8, so half of that is 4 for our amplitude. Okay. We will pick up where we left off after your lunch. We've determined that our amplitude is 4 and we have a reflected sine graph, so A is negative 4. Okay. If I were to draw the frame, this is how we would draw it. Connor, what's the length of this period? 2. So our period is 2. We calculate the period 2 pi over b. So 2 pi over b equals 2. Some of you are going to be able to figure these out in your head. Some of you are going to need to do some cross multiplication. Okay, so 2 pi equals 2b, divide by 2, b equals pi. The starting point for our frame, Molly, where is it?
0, 0.
Right here?
Oh wait, 0, 2.
Right here? I like that better. Okay. So our starting point is at 0, 2. And if our starting point is at 0, 2, then that means C over B equals 0 and D equals 2. Well, C over B equals 0, C has to equal 0, right? It doesn't even matter what B is. Okay? So the equation of this, the equation of this graph, y equals -4 sine of bx. There's no c to worry about, but then we'll add 2 to the end for our plus b. Any questions so far? All right, one more graph that does not have a starting point on the y-axis. And then I'll give you some time to work. Okay. Go ahead and take a little bit of time to draw that. To at least have marked the -pi/6, the pi/2, and the -2 and 2. That would be bare minimum I would want you to have for your notes. Okay. Will, sine or cosine? What'd you say? Okay. And is it regular or reflected? It's reflected. So we're going to go ahead and label our A is going to be a negative value. Okay. Finn, what's our amplitude?
2.
2. Very good. We have a vertical height of 4, so our amplitude is 2. So A is -2. All right. Here's where it gets fun. Our period. We stretch from -pi/6 to pi/2. How do we find how long that stretches? Okay, I want to use a different word than at, though, okay? If we take where we end and subtract where we start, we will get the length of that frame, okay? If you take end minus beginning, you will get the length. So, our frame ends at pi/2, and we'll subtract where it stops at -pi/6. Okay. Gabe said common denominators. All right, so we have 3pi/6 plus pi/6. What does that give us? 4pi/6, which is 2pi/3. Okay. So if the period is 2pi/3, we know that that has to equal 2pi/b. You can either cross multiply physically on your paper. Some of you are going to cross multiply in your head. That is fine. Our b value is 3. Be careful. This is a cosine graph. This is where the starting point gets a little funky. Okay. Cindy, where is our starting point? Right here? Is that where we would start our frame if we were drawing it? No. Okay, so where should it be instead? I like the negative pi over 6. But instead of negative 2, where should we move it to? Okay, our starting point is always in the middle of the frame, okay? Remember, the cosine is going to start in the corner of our frame, but the starting point is in the middle on that left side. So our starting point is negative pi over 6, 0. Okay? So, if our starting point is negative pi over 6, 0, let's just go ahead and label right now d is 0. Let's just get that out of the way. All right? Then we know that c over b needs to equal negative pi over 6. Do we know what b is? Okay? You have to find a and b before you can find c. Okay, you might as well go in alphabetical order. So we know that b is 3. So now to solve for c, we can multiply this 3 over. So c is negative 3 pi over 6, which is the same thing as negative pi over 2. So when we go to write this equation, forgot what our a was. We have a cosine of bx minus c. Since our c is negative, it turns into a plus. We have 3x minus negative pi over 2. And then since d is 0, we do not have to say plus 0. We can just leave it. If you write plus 0, I'm not going to be upset, but it's not necessary. Okay. Biggest thing about writing these equations is just setting up. I mean, you basically have to identify amplitude to help you with A. You have 2 pi over b for period. You have c over b for that x of your starting point. Those are the two biggest things that you're going to have to solve for. Okay, and use some algebra. So I'm going to give you some time to begin your worksheet. Okay. And this is what I'll be checking on Monday.